First, still some more time.
Okay.
Can we start?
Yeah, uncle. I got late today, uncle. So, sorry.
From school, huh? Okay, no
Yeah.
problem. We'll take 5 minutes more to finish then. Okay. Exercise 10.3. I don't know if you are able to do any of the sums in 10.2. The leftover.
I was trying, uncle, but I might need to do it once again. I went somewhere wrong.
8 and 6 was homework.
Yeah.
Did you do 6 at least? No? You were able to do 6?
I tried 8, uncle, but somewhere I went wrong. So I tried doing the whole sum again.
Oh, okay. Try 6 then. 6 might be easier.
Okay, uncle.
But 8 has got less activity.
Hmm.
8 has got less activity. Okay, you finish it and send a screenshot. Even if you are not able to get it right, till what you have done, you send a screenshot.
Sure, uncle.
We'll
Yeah.
see how it is done. Okay.
Hmm.
Today, let us try and look at exercise 10.3. Okay. 10.3. There are 15 problems. Let us see if we can do some of these problems. Exercise 10.3. The critical path of the following network is which one? You yourself can tell now. You can tell, or we can try to do it and you can tell. Let us see. Oh, I didn't put my tablet on. 1 second. All this 9th standard mathematics you did long ago. Okay. Let us try to do exercise 10.3. Critical, choose the critical part. 1, 2, 4, 3. Mm, 20, 25, 5, 8. Okay. Let us do the forward pass for this one. We have to do E0 equal to 0. Then E2 is equal to 20. E3 is equal to 25. Then E4, two things come. 25 plus 5 is 30. So maximum of E4 is equal to maximum of 25 plus this 5 will be 30, or E2 will be 20 plus 12, 32. So this will be 32. Maximum 30 or 32 will be 32. Then from here E5 will be that also got two things. E3 is 25 plus 8. E5 will be maximum of E5 25 plus 8 is equal to 33, or 32 plus 10 is 32 plus 10. Okay, equal to 42. So E5 is equal to 42. L5 equal to 42. Now you get backward pass. Backward pass, you are coming only one direction. So this will be 42 minus 8 will be 34. Or this way also it can come back. So it can come back this way. You will have to have minimum of 42 minus, okay, E3. Before E3, I think we have to do E4, L4. Okay. So L4 is equal to 42 minus 10. Only one direction, 42 minus 10. So L4 is equal to 32. So these are same. These are also same. So 4 and 5 are on the critical path, that you know. And next, let us see. From 32, you minus 5. 32, from this 32, you minus 5, 27. Okay. This is a minimum of 2. Then from 42 minus 8, 34. So this is minimum. So 27. L3 is equal to 27. Now what you have to do? You have to find L2. L2 is one direction, and this direction also L2. Okay, so it is L2 is equal to minimum of L3 minus 10, yeah, minus 10, or L4 minus 12. L3 minus 10 is equal to, L3 is 27 minus 10 equal to 17. Now this one is coming. 27 minus 10 is 17. Or L4 minus 12. 32 minus 12 is equal to 20. No, this one will not come. Okay, this one will not come. This is only that 20 only. Only one direction. Then L0 is equal to, we still have this one coming. Okay, L3 minus 25. That is 27 minus 25 is equal to 2. Or L2 is minus 20. That is L2 is 20 minus 20 is equal to 0. So 0. Okay, L0 is equal to 0. Now what you have to do? What is the critical path? 0, 0. 20, 20, 32, 32, 42, 42. So you have 1, 2, 4, 5. That is a critical path. Okay. Is that answer one of the answers? 1, 2, 4, 5 is A. So A is a critical path. All right. Quite a difficult sum only this one. Why they are giving in multiple choice question? I don't know. Okay. Anyway, 1, 2, 4, 5 is the correct answer. So this one becomes critical path. Okay, let me paste this and we move to the other one. Maximize z equal to 3x1. So the function is to maximize z equal to 3x1 plus 4x2 subject to 2x1 plus x2 less than or equal to 40 and 2x1 plus 5x2 less than or equal to 180. Okay. X1 equal to 18 means 36 plus x2 is equal to 24. No, this first one is not true. X1 equal to 15, 2 into 15, 30 plus x2 is equal to 30. So 30 plus 30. No, this is also not less than 40. So not 1 and 2 are not true. Third one, let us try. 2 into x1 plus 35. Yeah, this one is fitting. 5 plus 35 less than or equal to 40. Yes, this one is fitting. Let us see the other one. 2 into 2.5 plus 5 into 35. Correct. 35. 175 plus 5. That's also equal to 180. So third one is correct. Okay. So the C, answer C. X1 equal to 2.5 and X2 is equal to 35. This is the right answer for exercise 10.3 second sum. Okay. This is simple sum. This is a multiple choice question sum. The first sum was a very big sum. Okay. This come. Let us try the third sum now. Long back we did all that sums. One of the conditions for the activity I comma j to lie on the critical path. Okay. E of, okay, 4 choices are given. One of the condition for activity to lie on the critical path. Okay. E of j minus E of I comma j. Okay, so j will be the last one. I will be the first one. Okay. Again, j is last one. I is previous one. Okay, correct. Is equal to T of I comma j. Okay, T of I comma j. Correct. That is correct. I then j. No, it's not correct. J and I then j. No, not correct. Third one also not correct. J minus I, yes, not equal to. No, this is not. Obviously, this is wrong. So first one only correct here. Okay. So sum number 3. This one only correct. E of j minus E of I equal to L of j minus L of I is equal to T of ij. Okay, that is the thing. Okay, earliest finish time minus earliest start time, latest finish time minus latest start time, which will be equal to the time. No, so we had that. No, earliest start time, early finish time, latest start time, latest finish time. So this is 0, this is 8, this is 0, this is 8. Then both are correct. Okay, and the difference is the duration. Duration is 8. So this is T of ij and Lj minus Li. Lj is this one and Li is this one. Same way Ei and Ej. Okay, that's what it means. So this is correct. Exercise 10.3. Let us post it. In fourth sum. In constructing the network, which one of the following statement is false? Each activity is represented by one and only one arrow. I.e., only one activity can connect any two nodes. Okay. The head of two activities.
Uncle, two activities can be identified by same head and tail events. I think it's that one, Uncle.
That's false, huh?
Yeah.
Because first one is correct. Two activities can be identified by the same head and tail events. Maybe, okay,
Arrow should not cross each other. That also is correct, Uncle.
Arrows should not cross each other. I think that is the better answer. D only is right. So let us go with D. Nodes are numbered to identify an activity uniquely. Tail node starting point should be lower than the head node end point. And that's all correct only. Okay, D only I think is the best answer for wrong.
Yeah, Uncle.
Not B. B looks like it is wrong, but arrows should not cross each other is very. Arrows should not cross each other. Two activities can be identified by the same method. Both are seeming correct. I don't know which one they have put this. Both B and D are wrong. Both are false. Two activities can be identified by the same head and tail events. Definitely not possible. Okay, let us see B only. Take it as B. This confusing fellows, these idiots giving questions like this. Arrow should not cross each other. Yeah, arrow should not cross each other is true. Yeah, it's true. So B only is correct.
Okay, Uncle.
Only wrong. B da correct. Wrong. Arrow should not cross each other is true. Nodes are numbered is true. A is also true. B only is false. So B is the thing. Okay. Fourth one. Okay. Now, no, nothing to work out about that. 5. In a network, while numbering the events, which one of the following statement is false?
Uncle, event number should be unique. That is true, Uncle.
Okay.
Event numbering should be carried on a sequential basis from left to right. That's also true, Uncle.
Okay.
The initial event is numbered 0 or 1.
Yeah, that's also true.
Okay, Uncle. Then the D is wrong, Uncle. The head
D
of
is
the
wrong. Head of the arrow. Oh, head of the arrow should bear.
Head of the arrow should always bear one
Number lesser than the one assigned at the tail. No, it should be opposite.
Opposite, yeah.
The head of the arrow should bear a number lesser than that. It should be opposite. It should be greater. Okay. So D, no? D is the answer. Okay. A solution which maximizes or minimizes the given LPP is called
an optimal solution.
feasible solution. A solution that maximizes or minimizes the given LLP. Okay, it's called optimal solution. Very good. Okay. Yeah, it is not just a solution because it is maximizing or minimizing. Okay. Okay, it's an optimal solution. Okay. Okay, seventh one is also very tough sum. Why they are giving sums like this? Okay. In the given graphs, the coordinates are M1. What you have to do now, solve. One line is okay, this is one line. One line is 4x1 plus 2x1 equal to 80. The other line is, that is this line. The other line is 2x1 plus 5x2 equal to 120. Okay, now let us put both these together. You divide this by 2. Okay, 2x1 plus x2 x2 is equal to 40. Same 2x1 plus put this on top. 2x1 plus 5x2 is equal to 120. Now you subtract, this will cancel out. 5x2 plus minus x2 is 4x2. 4x2 is equal to 80. x2 is equal to 20. So 2x1 plus x2 is equal to 40. So 2x1 plus 20 is equal to 40. 2x1 equal to 40 minus 20 is equal to 20. 2x1 equal to 20, x1 equal to 20 by 2 is equal to 10. Okay, so x1 equal to 10 and x2 is equal to 20. That is the intersecting point. X1 equal to 10, x2. Okay, C. C is the right answer then. This is which sum? 7th sum. 7th sum you got. Now what you have to do? 8th sum. The maximum value of the objective function z equal to 3x plus 5 subject to the constraints x greater than 0 and 2x plus 5y less than 10. ஒரே ஒரு constraint தான் இருக்குதா? Only one line is there. Then you have to find out the maximum value of the objective function. So let us do that sum. Exercise 10.3. 10.38 sum. The line is 2x plus 5y equal to 10. We'll take that. You know, x equal to 0, 5y equal to 10. Y is equal to how much? 10 by 5 is equal to 2. Okay. So 1 point is 0, comma 2. 1 point is 0, comma 2. Okay. Now you put y is equal to 0. Y is equal to 0 means 2x equal to 10. X equal to 10 by 2 equal to 5. Correct. So 5 comma 0 is the second point. So the line is like this. 0, 2. 0, 2 and 5, 0. 1, 2, 3, 4, 5. Let's put like that 5, 0. Okay, so all this is feasible area. So here you have 3 points, A, B, and C. A for a point A, okay, what is the function? Z is equal to 3x plus 5y. Okay, first point is 0, 0, x, y. 3 into 0 plus 5 into 0 is equal to 0. Okay. So this is one thing. Then z equal to 5, 0. 3 into 5 plus 5 into 0 is equal to 15. Then the other one is 0, 2. That is 3 into 0 plus 5 into 2. That is equal to 10. Okay. Of this, 15 is the greatest. So B answer is 15. That is the maximum value. Correct? Yeah. Maximum value is B. Okay, good. Let us put that also in. Okay, this is the 8th sum. Then we have to take 9th sum. What is 9th sum telling? The minimum value of the objective function x equal to z equal to x plus 3y. Okay, that is the function. Constraints. Okay, two constraints are given. 2x plus y less than or equal to 20. X plus 2y less than or equal to 20. Okay. Now, okay, let us do this sum now. Ninth sum. Okay, minimum values we want to find out. Okay. 2x plus y equal to 20. Okay, x equal to 0. Then y equal to 20. Then y is equal to 0. 2x equal to 20. X equal to 10. So the point is 10, 0. And this point is 0, 20. This is one line. Okay, now go for x plus y is equal to 20. Here put x equal to 0, then y equal to 20. So that means 0, 20. Again, same point only is coming, 0, 20. Then put y is equal to 0, then x equal to 20. So you get 20, 0. Okay, so 4 points, 1 point is repeated. So what you are going to do, 0, 0, then 1, 2, 3, 4, 10, 0, 0, 20, 1, 2. Let us say 0, okay. We'll take double the scale. 10, 10, 0 is here. Then 0, 20 is here. 20, 0. This is 20, 0. 20, 0. I don't know how to draw the graph for this, but let's do maximizing function. Z equal to x plus 3y. Okay, values 0, 0, x plus 3y. Z equal to x plus 3y. 0 plus 3 into 0. That is equal to 0 only. Then 10, 0 is the next point. You have to find minimum, minimize. Minimize z. 0, 3y. Okay, 10, 10 plus 3 into 0 is equal to 10. This is the second one. Third one is the second point. 20, 0. 20, 0. Another point. 20 plus 3 into 0. That is equal to 20. Then another point is 0, 20. That is equal to 0 plus 3 into 20. Is equal to 60. This is maximum. This is 0. 0 is minimum. Minimum value is 0. So minimum z equal to 0. So answer again is C. C is 0. Okay. Exercise 9 sum. 9 sum. C. Okay, this also done 9 sum. Now we have to go to 10 sum. Which of the following is not correct? 10 sum. Which of the following is not correct? Objective that we aim to maximize or minimize. Objective function is the one if we aim to maximize or minimize. Okay, correct. Constraints that we need to specify. Okay, constraints we need to specify. Okay. Decision variables that we need to determine. Okay. X1 and Y, X2 we need to find out. Okay. Decision variables are to be unrestricted. I think that one only is not correct. Okay. Then some D. Decision variables we need to determine is correct. Decision variables are to be unrestricted is not correct. Okay. So least likely answer 10th sum is D.
Okay, uncle.
Okay, let us do 11th sum. You tell me 11th sum. In the context of network, which of the following is not correct?
A network is graphical representation. That's correct, uncle.
It's correct. Okay.
A project network cannot have multiple initial and final nodes. That's also correct, uncle.
Correct.
A narrow diagram is essentially a closed network.
Yeah.
That's also.
I think that's also correct. Yeah.
Yeah, uncle. So it's again it's the uncle. An arrow representing an activity may not have length and shape. That's wrong, uncle.
Very easily you can find out. This is wrong. Okay, 11.
If you know A, B, and C is correct, you will know D is wrong, uncle.
This is very easy. Okay, very easy. 11th sum. Okay, let us go to 12th sum. The object of network analysis is to minimize total project cost. No, cost will not come in network analysis. Only duration will come. Minimize total project duration. That is correct. Find out the total duration within which it can happen. Okay. Then minimize production delays, interruptions, and conflicts. No, that cannot be done using network diagram. Production delay you cannot avoid. Network diagram will not be able to minimize production delays, interruption, and conflict. Okay. All of the above is not correct because minimize total project cost is not correct. So B only is correct.
Okay.
B only is correct. Minimize total project duration only is correct. Okay. 13 sum. Network problems have advantage in terms of project and
Scheduling, uncle.
scheduling
Option A.
module, actually. Yeah.
Okay.
Scheduling, but wait. Planning, yeah, planning also.
Okay, planning also.
Controlling also.
Okay, so it's all of the
All
above.
of the above, yeah.
Okay, uncle.
All of the above. Yeah, mainly scheduling, but planning and controlling also. When something goes wrong, the network diagram will be changed. Network problems are advantage in terms of project scheduling, all of the above, correct. Yeah. In critical path analysis, the word CPM means
Critical path management, okay.
critical path method, I think, not management.
Okay.
Yeah. A only is correct. Critical path method, not critical path management. Critical path method. So that's easy one. Critical path method. Then, given an LPP, maximize Z equal to 2x1 plus 3x2, subject to the constraints x1 plus x2 less than or equal to 1, 5x1 plus 5x2 less than or greater than or equal to 0. This is a trick sum, only a trick sum. Okay. See, problem will be one equation is put both ways. Constraints 5x1 plus 5x2 greater than or equal to 0. 5 into x1 plus x2 greater than or equal to 0. Now you put equal to 0. Okay. That is x1 plus x2 equal to 0. This is one constraint. The other constraint is x1 plus x2 less than or equal to 1. So x1 plus x2 equal to 1. So these two are contradictory. Either x1 plus x2 equal to 0 or x1 plus x2 equal to 1. So that these two lines will never meet. It's not correct. So best solution in that case, let us see. No feasible solution. I think no feasible solution. Unique optimum solution, no, you cannot get. Multiple optimum solution also you cannot get. No feasible solution is the best answer for that. Okay, no feasible solution is the best answer. Okay, over then. Let us, I think we have finished, what is this chapter called? Operations research. Okay. Operations research is over. What next chapter that we have to take? We can take tomorrow, no problem. Only 10 more minutes left. Matrices we already finished, right? Descriptive statistics we finished. Correlation regression we finished. Should we take financial mathematics or we will take algebra?
Algebra, uncle. We can algebra.
Algebra, huh?
Yeah.
Okay, next we'll do algebra then. But we'll do it next class.
Sure.
Okay, let us just 5 minutes, we can revise whatever we found out. Then we can finish. Okay, you can read this thing.
Yeah.
Summary, you can read.
Linear programming problem LPP is mathematical modeling technique which is used to allocate limited available resources in order to optimize, maximize, or minimize the objective function. And then short form of LPP.
Linear programming problem.
Yeah.
Okay.
Maximize or minimize Z equal to n sigma j equal to 1 Cj xj.
Aj is equal to 1 to n. Okay.
Subject to n sigma j, that's j 1 uncle no? Below that.
Jn equal to 1 to n.
Okay. ACJ AJ is lesser than or equal to, or yeah, is lesser than or equal to or greater than or equal to
Or
B.
equal to.
Hmm.
Constraints can be three form: less than or equal to, greater than or equal to,
Hmm.
b of I. Okay.
I equal to 1, 2, 3 till m, so
Okay.
on.
Hmm. And x
And
of 3
xj is lesser than or equal to 0.
greater than or equal to 0.
Yeah, greater than or
It
equal
must
to
not
0.
be negative.
Yeah. Objective function. A function z is equal to c1 x1 plus c2 x2 plus and so on cn xn,
Hmm.
which is to be and which is to be optimized. Maximize or minimize is called objective function.
Uh,
Yeah.
correct. It's the
Uh,
same as this one.
yeah, same uncle.
Same as that one.
Hmm. Decision variable. The decision variables are the variables we seek to determine to optimize the objective function xj, j is equal to 1, 2, 3, and so on, and other
Yeah,
decision variables
that part of it. I mean, what we are saying is
to optimize. Yeah.
this is x1, x2, x3, xn. Okay, those are the decision variables: x1, x2, xn. In a graphical method, you can only do two decision variables: x1 and x2 only. Cannot go solve beyond two variables. Okay. Yeah. Then
Okay. Decision variable. The decision variables are the variables that satisfies all the constraints of the problem, and non-negativity restrictions is called a feasible solution of the problem.
solution, not decision
Hmm.
variable.
Okay, solution. A set of values of the decision variables xj is equal to 1, 2, 3, and so on, and satisfying all the constraints of the problem is called solution to the problem.
So there will be a solution uh,
For every sum, there's a
where
solution.
x
Okay.
of 1, x of 2, x of 3 and all is able to get. Okay.
Hmm.
Hmm.
And then feasible solution. A set of values of the decision variables that satisfies all the constraints of the problem and non-negativity restrictions is called a feasible solution of the problem.
At the same time, that x of I and
Non-negativity.
x of 1, x of 2 will be non-negative. They must
Hmm.
be greater than or equal to 0.
Okay. Optimal solution. Any feasible solution which maximizes or minimizes the objective function is called optimal solution.
Okay. Now, feasible solution, which is giving the maximum if you want z equal to maximum, or minimum if you want z equal to minimum. Z is the objective function.
Hmm.
Okay.
Okay. Can you scroll down? Okay. Yeah. Feasible region. The common region determined by all the constraints, including non-negative constraints, xj is greater than or equal to 0
Hmm.
of a linear programming problem is called the feasible region
Hmm.
or solution region for the problem.
Yeah. Inside the solution region, there will be some extreme points that only will be the optimal solution. Okay.
Hmm.
So that you have to find out. Okay.
Linear programming problems which involve only two variables can be solved by graphical method.
Yeah, that's why C1 x1 plus C2 x2. Up
Hmm.
to that z, if z is like that, object function is like that,
Hmm.
then we can solve that problem by graphical method. Otherwise, you cannot solve it graphically.
Okay. It should be noted that the optimal value of LPP occurs at the corner points of the feasible region.
At 0, A, B, at O, A, B, C, D, like that. At the corner points only, optimal values are occurring, not inside the region. Yeah.
Hmm. Network is a diagrammatic representation of various activities concerning a project arranged in logical manner.
Okay. Okay. This also we can read.
Okay. An activity is a task or item of work to be done that consumes time, effort, money, or other resources.
Hmm.
The beginning and the end points of an activity are called events or nodes.
Hmm.
Critical path. The longest path connected by the activities in the network is called critical path, a path along which it takes the longest duration.
Before that time, the project cannot be completed. It will take at least that much time to complete the
Hmm.
project. Okay, I think that is enough. We can wind up this thing, and maybe when you finish all the other things, if you have time, you can come back
Sure.
and
Okay. Yeah, yeah, yeah.
have a revision. Okay,
Maybe we
you
should like
finished.
do a good revision for this, uncle. It's like a bit
Okay,
tough only.
okay. I thought we should start financial mathematics.
Yeah, we
Maybe we
should.
can finish the last four at least. You are
Okay,
telling
uncle.
algebra. What we'll do? Okay, I'll let me come back to you day after tomorrow. Hmm?
Sure, uncle. Yeah.
Okay.
Okay, uncle. I
Okay.
leave now.
Bye now. Yeah.
Bye,
Today
uncle.
we learned 5 minutes earlier. Thank you.
Yeah. Good night. Bye
Bye.
bye.